Welcome to first order differential equations, separable equations, part 2. Example 1. dy over dx equals to 3x squared plus 4x plus 2, 2y minus 2. In this differential equation, we have been given initial condition y0 equals to minus 1. Remember, 0 is the value of x and minus 1 is the value of y. Now let's separate the variable. 2y minus 2 dy equals to 3x squared plus 4x plus 2 dx. We can now integrate both sides to get the answer. So we have the integral of 2y minus 2 dy equals to the integral of 3x squared plus 4x plus 2 dx plus, of course, constant of integration. When we integrate y, we get y squared over 2 and 2 will cancel, so we have y squared minus. When we integrate 2 with respect to y, we get 2y equals 2. When we integrate x squared, we get x cubed over 3 and 3 will cancel, remaining with x cubed, plus when we integrate x, we get x squared over 2. 4 divided by 2 is 2x squared. And when we integrate 2 with respect to x, we get 2x equals to c. Now, we can now insert our initial condition. X is 0 and y is minus 1. So we have minus 1 squared minus 2 minus 1 equals to 0 cubed plus 2 0 squared plus 2 0 equals to c. Now, negative 1 squared will give us 1. Minus 2 times minus 1 will give us plus 2 equals to 0 plus 0 plus 0 is 0. So we'll have c. Now, the value of c is given by 3. So we can go back to our general solution and insert the value of c. So our particular solution will be given by y squared minus 2y equals to x cubed plus 2x squared plus 2x plus plus 3. This is our particular solution. Example 2. dy over dx equals to x squared 1 minus y squared. Let's cross multiply. We have 1 minus y squared dy equals to x squared dx. We can now integrate both sides to get the answer. The integral of 1 minus y squared dy equals to the integral of x squared dx plus, of course, constant of integration. When we integrate 1 with respect to y, we get y. So we have y. When we integrate y squared, we get y cubed over 3. So we have y cubed over 3 equals to, when we integrate x squared, we get x cubed over 3 equal plus constant c. We can multiply all the terms by 3, so we have 3y minus y cubed equals to x cubed plus 3c. C is a constant. A constant times 3 is another constant, say c. So we have 3y minus y cubed equals to x cubed plus c. We can write this one as x cubed minus y cubed minus 3y equals to constant c, and this is the required general solution. Now let's go to example 3. X y squared plus x dx plus y x squared plus y dy equals to 0. Now let's start by factoring x. So we have x y squared plus 1 dx plus, we can also factor out y. So we have x squared plus 1 dy equals to 0. Let's divide by y squared plus 1 and at the same time by x squared plus 1. Y squared plus 1, x squared plus 1. Y squared plus 1 will cancel, remaining with x over x squared plus 1 dx plus x squared plus 1 and x squared plus 1 will cancel, remaining with y over y squared plus 1 dy equals to 0. Since we have separated the variable, we can now integrate. So we have the integral of x squared plus 1 dx plus integral of y squared plus 1 dy equals to constant c. For us to be able to integrate x squared plus 1 and y squared plus 1, we need to use the concept of u substitution. So let u be equal to x squared plus 1. Our du dx will be equal to 2x. Therefore, our dx equal to du over 2x. Similarly, let v be equal to y squared plus 1. dv dy will be equal to 2v. Therefore, our dy will be equal to dv over 2v. We can now make the substitution. So we have the integral of x squared plus 1 is the same as u, then dx is the same as du over 2x, plus the integral of y squared plus 1 is the same as v, and dy is the same as dv over 2v, of course, equals to the constant of integration. Now, we can simplify x. So we have 1 over 2, 1 over u du, plus again v and v will cancel. We have 1 over 2, 1 over v dv equals to c. Now 1 over u, the integral of 1 over u is ln u. So we have a half ln u plus a half, the integral of 1 over v is ln v equals to c. So we have a half ln u. But remember, u is x squared plus 1 plus a half ln v. V is y squared plus 1 equals to c. Now, we can multiply all the terms by 2. So we have ln x squared plus 1 plus ln y squared plus 1 equals to 2c. But c is a constant. A constant times 2 is another constant, say c. So we have ln x squared plus 1 plus ln y squared plus 1 equals to c. Now, a property of ln allows us to take ln x squared plus 1 y squared plus 1 equals to c. Now we can raise both sides to exponent. So we have the exponent of ln x squared plus 1 y squared plus 1 equals to the exponent of c. Because we have exponent and ln, these two will cancel, remaining with x squared plus 1 y squared plus 1 equals to the exponential of c. The exponential to the c is another constant, say c. So this is the required general solution. Example 4. X dy over dx plus cot x plus cot y equals to 0. In this question, we have been given initial condition y root of 2 equals to pi over 4. This is our x and this is our y. Let's start by multiplying both sides by dx. We have x dy plus cot y dx equals to 0. Now, we can divide by cot y and at the same time by x, cot y, x. X and x will cancel, so we have 1 over cot y dy plus cot and cot will cancel. So we have 1 over x dx equals to 0. Since we have separated the variables, we can now integrate both the terms. So we have the integral of 1 over cot y dy plus integral of 1 over x dx, and this is equal to the constant of integration. Now, what we need to know is that cot y, the inverse of cot y is the same as tan y. So we can say the integral of tan y dy plus the integral of 1 over x dx equals to c. The integral of tan y is equal to ln sec y plus, of course, the constant of integration. So we have ln sec y plus the integral of 1 over x is ln x equals to constant of integration. Again, a property of ln allows us to take out ln, then multiply x and sec y, and again equate this one to c. We can raise both sides to exponent, so we have exponent ln x sec y equals to the exponent of c. Exponent and ln will cancel. We have x sec y equals to exponential to the c is a constant, say c. Up to this point, we can now insert our conditions. Our condition were y root of 2 equals to pi over 4. Remember, this is x and this is y. So we have root 2 sec pi over 4, and this is equal to c. So we have root of 2. Secant of pi over 4 is the same as root of 2 equals to c. Therefore, c equals to 2. Because root of 2 times root of 2, we get root of 4, and root of 4 equals to 2. Therefore, our particular solution is given by x sec y equals to 2. Now, this is the required particular solution. Example 5. Y plus yx cubed dy minus x squared dx equals to 0. Let's factor out y. So we have y into 1 plus x cubed dy minus x squared dx equals to 0. Let's divide both terms by 1 plus x cubed. Now we have y dy minus x squared 1 plus x cubed dx equals to 0. We can now integrate both sides. So we have the integral of y dy minus the integral of x squared 1 plus x cubed dx equals to 0. We know that the integral of y is y squared over 2, but for us to be able to integrate this, we need to use the concept of integration using u substitution. Let u be equal to 1 plus x cubed. Our du dx will be equal to 3x squared. Therefore, our dx is equal to du over 3x squared. So back here now we have the integral of x squared over u, and our dx is the same as du over 3x squared. So we have y squared over 2 minus x squared, and x squared will cancel. We can pull out 1 over 3. Integral of 1 over u du, and of course this must be equated to constant c. So we have y squared over 2 minus a third ln u equals to c. So we have y squared over 2 minus 1 over 3 ln u. But what was u? U was 1 plus x cubed. 1 plus x cubed equals to c. Now we can multiply all the sides by 6 in order to eliminate the denominators. So we have 3y squared minus 6 minus 2 ln 1 plus x cubed equals to c. This is the required general solution. Example 6. Y squared dx minus x squared dy equals to 0. Now let's separate the variables. So we have x squared y squared, x squared y squared. Y squared and y squared will cancel, so we have 1 over x squared dx minus x squared and x squared will cancel. We have 1 over y squared dy equals to 0. Let's integrate both sides. So we have the integral of 1 over x squared can be written as x to the power minus 2 dx minus the integral of y to the power of minus 2 dy equals to constant c. So this one gives us minus x minus y to the power of minus 1 equals to c. Now this can be written as minus 1 over x, minus and minus will be plus 1 over y equals to c. So this is the same as 1 over y minus 1 over x equals to c. And this is the required general solution.